Okay, we are now getting on to some of the rules that are important to work out and to be able to differentiate more functions in a tech-free situation. When we say the word the product rule, you should be remembering that product means times or multiplication. So we are doing this when we have two different functions that have been multiplied together. And that is the instances when we'll be using the product rule. Let's have a look at the formula. So the formula says that if we have two functions that have been multiplied together, g of x and h of x, then to calculate the derivative, we differentiate one of these functions and multiply by the other, h of x, plus we differentiate the other function and multiply it by the second. Because this is a plus in the middle, it does not matter the order. These can be written in either way, and that is completely fine. On the formula sheet, this will be written in a different format, and you'll actually see it written as d du, so the derivative of two functions, u and v. And in order to differentiate this, they say we keep the first function and multiply by the derivative of the second, plus we keep the second function and multiply by the derivative of the first. Now these rules are actually saying the same thing, they're just written in different ways. What you're hopefully noticing with the product rule is that what we are doing is we are differentiating one function, multiply it by the other, plus the derivative of the second function multiplied by the first. So let's look at some examples. Okay, now similarly to the chain rule, we can actually define things if it helps. Or we can do it straight away using a shortcut. Personally, I prefer to use the shortcut, but you need to find what works for you, and you need to use a method that you are consistently getting the questions right. If we are defining these separately, we can define each part as either being g of x and h of x, or as being u and v. Given that the formula sheet has the derivative written, not dy, let me just quickly fix this up, okay? Given that the formula sheet has the formula written in the form d dx of u v equals, I keep making slight mistakes today, apologies for that, d du of u, keep the first multiplied by the derivative of the second, plus second multiplied by the derivative of the first. So let's use this for our first example. We would need to let the first part, because remember there is a multiplication sign when not written in between our two separate functions here. So we let u equal our first function and we let v equal our second function. We differentiate these using our techniques that we already know and that we've used previously. The derivative of x squared is 2x, derivative of 2 is 0. Then I differentiate dv dx. The derivative of 3x squared I multiply by the power, gives me 6. Subtract 1 from the power is x. Okay, so if we are now using our rule to find our derivative f dash x, we have, okay, let's carefully make sure we're getting the correct bits. We have u, our u is given here, so u, x squared plus 2, that has been multiplied by dv dx, and dv dx, the derivative of the v function is this one here, multiplied by dv dx, plus, so goes our formula. Oops, I wanted to change colour there just so I'm being consistent. Plus from our formula. Now we have the derivative of v, so we are now differentiating v, and our v formula is given here. 3x squared minus 4, it is all of v, so put it in brackets, all of v is multiplied by du dx, and du dx that's here is du dx, this bit here multiplied by du dx. Remember this formula here is given on the formula sheet, you do not need to remember it, you can refer to it. We can simplify this somewhat, and something to remember, while I often say there's no need to expand unnecessarily, we really need to give our answers as either fully expanded or fully factorised. In this case, our answer is a little bit of both. It's not quite expanded, it's not quite factorised. So if I expand, I would get 6x multiplied by x squared gives me 6x cubed, plus 2 times 6x is 12x, plus expanding the second, 2x times 3x squared gives me 6x cubed, minus 4 times 2x is 8x. Collecting like terms, 6x squared plus 6x squared is 12x cubed. Sorry. 12x minus 8x is plus 4x. And this is our final answer. Okay. Now the second one, and it is entirely up to you how you think about this, okay? So that's how we've worked that out, using the product rule. I'm going to show the second one by talking about the shortcut, by thinking about what actually happens. So what we're going to say is let's let y equal, because we haven't got a y or an f of x or anything else, our first function is x squared, and our second function is this one here, 2x minus 1, and let's write it with the power of a half. Okay, so we're working this out, and we need to use the chain rule as well in this case, okay? So when we're differentiating, there is lots going on here. You need to think very carefully about what you're doing step by step. So to differentiate, and again, remember, it doesn't matter which part we differentiate first, but if we're looking at what's going here, okay, we can say we differentiate the first, which gives me 2x, and we multiply by the second without differentiating. We only differentiate one part of my function at a time, okay? In this case, we differentiated the first function, multiplied by the second. Plus, okay, now we need to do the opposite this time. So last time we differentiated the first and multiplied by the second. So this time we need to leave the first as is, we leave it as at x squared, and we need to differentiate the second. But notice that to differentiate the second function here we need to use the chain rule. So we differentiate the outside function first. We multiply by our power, we leave what's inside the brackets as is, and we subtract 1 from the power. But for the chain rule, we also then need to differentiate our inside function. So we differentiate the inside part there. Derivative of 2x is 2, and derivative of negative 1 is 0. Let's simplify this if we can, because this is quite messy right now. For the first part here, we just get 2x multiplied by, rather than writing 2x minus 1, it's nicer to write it under the square root sign. The second part here, we can actually cancel 1 over 2 and 2 cancel out. So this can be written as x squared in the numerator. Because we've got a negative power here, we can move this part to the denominator. And 1 over 2 is the same as saying square root of 2x minus 1. We can leave it like this, or if I'm wanting a common denominator of square root of 2x minus 1, here is my denominator. If I need a similar denominator here, that means I need to be multiplying by square root of 2x minus 1 in the numerator and square root of 2x minus 1 in the denominator. That gives me the denominator. In the numerator, square root of 2x minus 1 times square root of 2x minus 1 will just actually give me 2x minus 1. So I get 2x from this part here, multiplied by 2x minus 1 plus x squared. If we expand, that would give us 4x squared minus 2x plus x squared over square root of 2x minus 1. And if we collect like terms, that would then give us 5x squared minus 2x over square root of 2x minus 1. Main thing here is to think very, very carefully about what you're doing each step of the way to make sure that you don't miss anything. Let's have a look again at another example. Okay, so we've got two more examples to look at, and notice that this time we're relying on knowing how to differentiate a whole lot of functions that we actually have looked at before. This time we can use rather than using the formula given on the formula sheet, let's use the other formula, the other way of writing it. However you choose to work these out is fine. I'm just trying to provide you with options, and you need to choose whichever works for you, okay? So that's the main thing that we're doing here. You're trying to figure out which option is going to work for you. So this is the other way we can look at this. If we're using this function, we need to start by defining our two separate functions as g and h. Remember, x log e of x, there is a multiplication inside when not written. So we can let g of x equal the first function, x, and h of x, our second part, equal log e of x. We then differentiate each of these. The derivative of g of x, g dash x, derivative of x is 1. Differentiate here, we get h of x, and the derivative of log e of x is 1 over x. That is on your formula sheet, and you can also refer that to the derivatives of logarithms video. So when we now work out our derivative, our original was y, so our derivative is dy dx. But how we're going to get this is by using our rule that was given before. We will have our g of x function, and that is going to be multiplied by h of x. And when we add to that, what we're going to get is our g of x function, which is multiplied by h dash x. So let's substitute in the values from the things that we've worked out earlier. G dash x is our function here is 1, and that is multiplied by h of x, our function here, which is log base e of x. Okay, we add to this and we get our g of x function, which is x, multiplied by h dash x, which is 1 over x. We can now simplify. So we multiply 1 times log e of x is just log base e of x, plus x times x is 1. And this is as simplified as we can get, and that is our final answer. Once again, there was a lot of ways of thinking about it. You could have instead used the formula on the formula sheet, which would have given you the same answer, or you could have used the shortcut method. For option D, we're going to look at using the shortcut method. So we're differentiating this. Another notation, another way of showing this is that we're saying d dx, we're differentiating this function. I'm just going to use two colours to clearly show what we're actually looking at here. So we're differentiating the first part of our function we can call 4e3x, and the second part of our function is the other one given here, which is tan of 2x. Okay, so shortcut way doesn't require us setting up g and h or u and v, but instead just requires you to think about differentiating one part at a time. So we differentiate our first function, the derivative of 4e to the 3x. What we need to do is to multiply by the derivative of the power. The derivative of 3x is 3, 4 times, so we get 4 times 3, e to the power of, and we leave the original function itself. That's how we differentiate. So we've now differentiated this first part here. and we multiply it by the second part, which we leave as is. Okay, now because I've differentiated the first section, when I add to this, I am now in the second part. Now I'm going to do the opposite. I leave the first function as is, I leave my blue function as is, and I'm going to differentiate tan of 2x. We differentiate the argument here, which gives me 2, and the derivative of tan x, hopefully you remember, is sec squared of the argument, sec squared of 2x. That was using the product rule. That was the product rule right there. So now what I do is I can actually simplify this and work it out. 4 times 3 gives me 12e 3x multiplied by tan of 2x, plus 4 times 2, so 4 times 2 here is 8 e to the 3x by sec squared 2x, which we can leave as sec squared 2x, or we can write as over cos squared of 2x. And that actually is a good enough answer. There is a number of other ways we can manipulate this to get to a final answer, but that is fine as it is. If you choose not to set up your product rule by actually defining g and h like we did here, you need to be very, very careful with what you're doing here. Multiply the derivative of the first multiplied by the second plus the first as is multiplied by the derivative of the second. The product rule is very important. You do need to know how to do this in a tech-free situation. Please make sure that you're practicing more of them. If you have any problems, write them down and ask me in the next lesson. Thank you very much.